Hi everyone, welcome to our first lesson for 7.5. The 7.5 notes are going to be broken into 4 parts, and today we're looking at part 1, and this is factoring quadratic equations using a fast method when we see a general trinomial. Let's go ahead and get started. So recall that when you have a quadratic function, to solve for the roots, we have to figure out what are the values of the x-intercepts. One method to solve for quadratic is to factor the quadratic equation. And we've actually already done this, and so this is a little bit of a review, this part 1. I'll remind you that to factor means write that quadratic equation as a product of its factors, or as a product of binomials. Okay, so we're going to write as a product of binomials. And those binomials are simply just the factors. Another way to say this is to put it in factored form. Factored form looks like this. Y is equal to A, okay, x minus r times x minus s. So s and r are the roots, and so that's really what we're trying to do, is figure out the roots by factoring these quadratic equations. We're going to see 3 types of quadratic equations. Okay, quadratic equations are generally trinomials, so you have that 3 terms in a trinomial: x squared, the 2x, and the 24. All 3 of those are separate terms. They're not like terms, so they cannot be put together, which means that in total we have 3, and that's where the word trinomial comes from, 3 terms. Okay, a general trinomial is one where the coefficient, the number in front of the x squared, is a 1. In other words here, this value right here, a, okay, is equal to 1. A trinomial that we would consider not to be a general trinomial is one where the number in front of the x squared is greater than 1 or less than 1, but it's not 1. Okay, so 2, 3, -2, -4, and we have to deal with these types of trinomials differently. The first scenario, a general trinomial, we can use a fast method, and that's what we're going to look at right now. Okay, a fast method. If x is anything other than, the number in front of the x squared is anything other than 1, we're going to factor by grouping, which is an easy method as well, but it's a little different, and there's an extra couple of steps involved. And then finally, in lesson 3 here, we're going to look at a quadratic that doesn't have that middle term, the x term. We have 25x squared minus 64, and these are special types of quadratics where it's a binomial because there's 2 terms, and both the first and the last term are actually perfect squares. And there's a method that we use to quickly factor those difference of square binomials. So we're going to start here today. And this is a bit of a review because we have looked at the fast method already. When we see any type of quadratic equation, we should always start by looking for the GCF, or some factor that's common to all terms in the quadratic equation that we could factor out. And if there is a GCF, if it's greater than 1, we're going to factor that out right away. This helps to simplify the rest of the factoring process. Just makes life a little bit easier for us. So let's go ahead and start. So part 1, we're looking at quadratic functions that have an equation which is a general trinomial. So again, I'm going to remind you, when you're looking at this, okay, the number in front of the x squared is going to be a 1. The coefficient there is a 1. Or if there's a GCF, after we factor that GCF out, we're left with a 1 in front. Okay, that's called a general trinomial. Here's our quick method. We're going to look for 2 terms, okay, or essentially 2 roots. And the way that we figure this out is that the middle term is the sum of our two numbers. And the last term is a product of those same two numbers. So if we look at this, this is our A. The number in front here is an A. A is 1 in this case. Okay, there's our B value. It's equal to -2. And there's our C value. Okay, that's just standard form. And we're looking for two numbers that when multiplied together give us that last term. Okay, they're equal to C. And those same two numbers have to add together to give us that middle term B. Okay, so that's what we're looking for. Let's go ahead and try this one out. So I'm looking for two terms, and here I'm just going to, instead of writing C and B, okay, let's put the actual values. So C here is -24, and B is -2. So I'm looking for two numbers that multiply to give me -24 and that add to give me 2. Okay, you can go through the factors of 24 if you want to, maybe on the side here. So we could think about it, 1 times 24, or let's say 1 times -24 is going to give me -24, but 1 plus -24 is not going to give me -2. Okay, then we could go 2 times 12. Okay, remember that one of these is going to have to be negative because we know that when we multiply, we get a negative number. So one must be negative and one must be positive. So I can already assume that right away. Okay, so let's think about this. 2 and 12 give me 24. All right, but -2 plus 12 doesn't give me -2. And -12 plus 2 also doesn't give me -2. So that's not going to work. Let's go to 3 and 8. Those are the next two factors. Okay, we're getting closer here. I know that they would multiply to give me 24. Would any combination of 3 and -8 or -3 and 8 give me -2? No. Okay, so that's gone. How about we try 4 and 6? Those are the next factors that give me 24. Okay, well, there is a combination of 4 and 6, if one was negative, that would give me -2. I can see here that if the bigger number here, the 6, was a negative value, -6 plus 4 would give me -2. So I found my factors. Okay, so we're going to come over here and say those are our factors, -6 and 4. And I'm going to do my quick double check. Yes, they multiply to give me -24. And yes, they add to give me -2. So I can now take those factors and I'm going to rewrite my quadratic equation in factored form. Okay, so as a product of binomials. So let's write. Okay, let's write product of binomials. Okay, which is the same as factored form. I already know my a value. A is equal to 1. Okay, so f of x or y, okay, it's also fine to say y, is equal to x, okay, minus 6 times x plus 4. Okay, so I've taken my two numbers. I'm going to now put them as part of my factors. And I can solve for the roots now. So I'm trying to figure out what are my x-intercepts. These ones are really easy. You can look at them and figure out immediately what the roots are. But a mathematical way to do this is just to set the quadratic equation equal to 0 and then solve for x. Okay, so this value here for y would be equal to 0 if x minus 6 was equal to 0. Okay, that would give me 0 as my answer because these two binomials are being multiplied by each other. So if either one of these sets of brackets was equal to 0, I would get a 0 for my y here. So I'm going to set each one equal to 0. Okay, so we have when x minus 6 equals 0, we can solve for x. So x, okay, if I move that 6 over to the other side so that I can isolate x, I would have to add 6 to both sides. You can also just export it over to the other side and change its sign if you prefer the export method. And so what we're going to get is x is equal to positive 6. Okay, there's one root. Okay, my other root is when x plus 4 is equal to 0. And again, you're going to isolate x by moving that 4 over to the other side, so we can subtract 4 from both sides, or you can export it over, and we get x is equal to negative 4. So in other words, when x equals negative 4 plus 4 would give me 0, okay, for that second binomial. So those are my two roots. And I've solved them. Let's do one more example here. On your next page, example 2 says, find the roots of the quadratic equation. Immediately when you look at this, you might think to yourself, oh, I can't use the fast method here because this is not a general trinomial. The number in front of the 3, or pardon me, the number in front of the x squared, which is a 3, is not 1. So it is true here, okay, immediately that a is not equal to 1. But you should always start, whenever you're factoring, by looking for a greatest common factor. And if there is one, factor it out. So let's ask ourselves, is there a GCF greater than 1 here? In other words, is there any number that will go into 3, 15, and 18? And there is. 3 will go into 3, 15, and 18. So 3 is a factor of all of those terms. So the GCF is 3. So let's factor it out. And if you were wanting to check quickly in your head, you're simply asking yourself, does 3 go into 3? Yes. Does 3 go into 15? Yes, it does, 5 times. And does it go into 18? Yes, it does, 6 times. Okay, so we're going to go ahead and factor that out. So we're going to rewrite this as f of x, which is the same as y, equals 3. There's my GCF, and that's also my value for a. Okay, let's take that factor out of all 3 terms, and we're going to write what's left. So 3x squared divided by 3 just leaves me with x squared. Negative 15x divided by 3 will leave me with negative 5x. And 18 divided by 3 is going to leave me with simply 6. Okay, so now that I've factored out that 3, what I see here is that what's left in brackets is just a general trinomial. And I can use the fast method here. Of factoring. Okay, so let's factor what's left inside. Okay, we'll keep that 3 there because it's still hanging out. It's important. Okay, so let's go ahead and factor. Okay, I've got 3. Just going to write it again for myself. 3 times x squared minus 5x plus 6. And I'll label them quickly. Okay, there's my a. Okay, there's my b. And there's my c. And I'm looking for 2 numbers that multiply to give me c, which is 6, the last term. And those same 2 numbers have to add together to give me b, which is negative 5, my middle term. As soon as I see, there's some hints here. As soon as I see that this middle term is a negative, I know right away that at least one of these terms has to be negative. The other thing that I notice is that this is a positive value. Well, because the product of my 2 numbers I'm looking for is a positive value, that means that both of these numbers have to be negative, because only a negative times a negative will give me a positive, or a positive times a positive will give me a positive, but that won't give me a negative here. So right away, there's some hints just to get you started. I'm looking for 2 negative numbers here that are going to multiply to 6 and add to give me negative 5. You might start to get quite fast at this. Thinking about it, what are the factors of 6? Well, there's not very many. You have 1 times 6. Would negative 1 times negative 6 give me 6? Yes. Would negative 1 plus negative 6 give me 5? Negative 5? No. Okay, so let's go to the next factors. How about 2 and 3? Well, I know negative 2 times negative 3 will give me 6. Will negative 2 plus negative 3 give me negative 5? Yes. So there are my 2 factors. Okay, negative 2 and negative 3 are the numbers I'm looking for. So we're just going to rewrite this general trinomial now in factored form. So here we have y is equal to, I'll keep that 3 there because it has to stay there. It's the value for a. And now instead of x squared minus 5x plus 6, I'm going to write x minus 2 multiplied by x minus 3. Okay? And then I'm going to go ahead and set this equal to 0 so that I can find the roots. Let's do that. One thing I want to mention here is that your a value does not become a problem for you when you're trying to find the roots. It's okay that there's a 3 outside of these brackets. You're still looking for a situation, okay, or in other words, a value of x that would make this first bracket equal to 0. And you're still looking for a value of x that would make the second bracket equal to 0. Even though there's a 3 out front, if one of these brackets simplified to be 0, that makes everything equal to 0. Okay, y will be equal to 0. So that a value out in front is not going to affect when you find the roots whatsoever. So let's go ahead and set both of those equal to 0. So x minus 2 is equal to 0. What's the value of x? Well, when x is equal to positive 2. Okay, I'm going to move that 2 over to the other side. So there's my one root. Okay, let's do the other one. X minus 3 is equal to 0. I'm going to move that 3 over to the other side by adding the opposite. I'm going to add 3 to both sides, and I get x is equal to 3. And there's my two roots. I found them. Excellent. I'd like you to try worksheet 7.5 part 1. And do pay attention to the number in front of your x squared, so your a coefficient, and always be looking first for GCF to factor out. And if you can, then if you're left with a general trinomial, we can use that fast method of factoring. Okay, thanks for joining me and good luck. Bye for now.